Today we're going to be talking about solving absolute value equations and inequalities. Here's our first absolute value equation. X minus 3 equals 7. Now when we're doing an absolute value equation, there are actually two possible answers where x minus 3 will equal 7. The first is where we just take the equation as is written. X minus 3 equals 7. We would add 3 to both sides. X equals 10. Simple. Now the other version is where we have to take the negative version of this equation. In this case, negative x minus 3 equals 7, or as we would normally write it, negative x plus 3 equals 7. At that point, we subtract 3 from both sides instead of adding. Negative x equals 4, which means x actually equals negative 4. Our next equation is going to be 2 absolute value of x plus 3 equals 17. Our first version is where we just basically treat the x as though it's an x. 2x plus 3 equals 17. We subtract the 3, 2x equals 14, divide by 2, x equals 7. On our other version, though, we're going to have to treat the x as though it's negative, meaning 2 times negative x plus 3 equals 17, or as I would normally write it, negative 2x plus 3 equals 17. Subtract the 3's, negative 2x equals 14, divide by negative 2, and now x equals negative 7. Our next equation is the absolute value of 3x minus 2 equals 8. 3x minus 2 equals 8 would be our original equation. We'd add 2. 3x equals 10, which means we divide by 3. We're not going to get a perfectly whole number. Instead, we're going to get a number that looks like this. 3.3 repeating, or 10/3. X equals that value. Our next equation would be negative 3x minus 2 equals 8. In that case, we distribute it to becomes negative 3x plus 2 equals 8. Subtract the 2. Negative 3x equals 6. Divide by negative 3. X equals negative 2. Our final equation that we're going to do is 1/3 of the absolute value of x plus 2 minus 1 equals 5. Now a lot of people would naturally want to first distribute that 1/3 into the x plus 2, but I'm going to tell us to wait and hold off on that. Instead, the first step I would recommend is just adding 1 to both sides. That means 1/3 of x plus 2 equals 6. Now, rather than multiplying by 1/3 and having to add or subtract to 2/3, I would much rather just get rid of the fraction altogether, and I would do that by multiplying both sides by 3. That means that x plus 2 equals 18, subtract 2, x equals 16. Now, our other version of this equation is 1/3 of negative x plus 2 minus 1 equals 5. I'm going to change that, and I'm going to change this in the future to just be 1/3 of negative x minus 2 minus 1 equals 15. Equals 5, not 15. All right, our first step is going to be adding 1 to both sides. 1/3 negative x minus 2 equals 6. Multiply by 3, just like before. Negative x minus 2 is now 18. So I would add 2 to both sides. Negative x is 20. Which means x equals negative 20. Now that we've done some absolute value equations, let's look at a few absolute value inequalities. The absolute value of x plus 2 is less than or equal to 6. Absolute value inequalities work pretty much the same way as absolute value equations. We just have to take into account what our inequality says. So, originally I would just write this as x plus 2 is less than 6. Is less than or equal to 6, forgive me. I would subtract 2 on both sides. X is less than or equal to 4. Now on the other side, I would go negative x plus 2 is less than or equal to 6, meaning negative x minus 2 is less than or equal to 6. Add 2. Negative x is less than or equal to 8, but because I'm going to now have to switch the sign and multiply by a negative or divide by a negative 1, that's going to change our sign to where x is now greater than or equal to negative 8. At that point, we would graph our points. Our highest point was a 4, our lowest point was a negative 8, and they would meet in the middle because it said that x was greater than -8, but less than +4. Here's another equation we have. In this case, 2x minus 1, the absolute value of that, is greater than 5. So our first equation is just that. 2x minus 1 is greater than 5. Add 1, 2x is greater than 6. Divide by 2, x is greater than 3. Our other equation, negative 2x minus 1 is greater than 5, becomes negative 2x plus 1 is greater than 5. Subtract 1. Negative 2x is greater than 4. Divide by negative 2. X is less than negative 2. We'd graph this, but please note we have to have open circles at negative 2 and 3, and also note that these would actually go outside because it says x is greater than 3, which means it would go to the right, and x is less than negative 2, which means it's going to the left. Really all this is saying is all the numbers from negative 2 to +3 are the answers that cannot work on this equation. Let's look at another equation. 3 absolute value of x plus 4 is greater than or equal to 13. That means that our circles are going to be filled in like the first question rather than open like the second question. Our first version, 3x plus 4 is greater than or equal to 13. Subtract 4, 3x is greater than or equal to 9. Divide by 3, x is greater than 3. The other version just changes into, I would subtract 4. Negative 3x is now greater than 9. Divide by negative 3. Remember that flips the sign, meaning x is less than or equal to negative 3. So if x is greater than 3, that means that goes to the right, and it's less than or equal to negative 3. That means that there's going to be a hole from negative 3 to 3. Here's our final inequality. 1/2 of the absolute value of x minus 6 minus 5 is less than 1. So our first version is 1/2 of x minus 6 minus 5 is less than 1. I'd add 5 to each side. 1/2 of x minus 6 is less than 6. Please note right here that we have 1/2 of x minus 6. And remember, I don't really like to distribute that 1/2. I would much rather personally multiply both sides by 2. That means x minus 6 is less than 12. Add 6. X is less than 18. On the other hand, we have 1/2 of negative x minus 6 minus 5. First step I do is once again add 5 because I'm going to change that negative x minus 6 to negative x plus 6. This becomes half of that is less than 6. I'd multiply both sides by 2 just like before. That means negative x plus 6 is less than 12 minus 6. Negative x is less than 6, which means x is greater than negative 6. Because the lowest value ends up being the negative 6 and x is greater than that, but x is less than our highest value, what we end up doing is we actually connect the dots. But remember, the circles will be open because of the fact that we are not actually including those two numbers. Now we have a couple word problems to go over. A jewelry company is making 16-inch bead necklaces. The specification allows for a difference of 0.5 inch. The function f of x equals the absolute value of x minus 16 represents the difference between the necklaces manufactured and the specifications. Graph the function. What necklace lengths meets the specification? So the first thing I'm going to do is graph the function. And I like this because the function is given to me. However, I do want to point out a couple odd things about this graph. The biggest thing is our y-axis right here. If you look right here, each value is by 0.1 rather than by a full 1. Meaning, when I go up from 16, I'm going to have to go up 1, which is actually going up 10, and then over 1. So up 10 over 1 because of how we ended up doing this image. That means it's going to look like this. Then what I'm going to do is I'm going to notice this 0.5 inch that we have right here. That means I'm going to find 0.5 inches on my graph. Here it is. And then I'm just going to draw a line across. That's our tolerance. Now the values below that tolerance are the ones that meet our specifications. The values above do not meet our specifications. Since we were asked what necklace links meet the specifications, I'm going to go from our lowest value to our highest value. Now if it's a little hard to read on here, you can also just take the 16 inches and add and subtract 0.5 inches to end up getting the necklace meets the specifications between 15.5 and 16.5 inches. Here's our last word problem. A cereal company is filling boxes with cereal sold by weight. Each box should contain 32 ounces of cereal. The specifications allow for a difference of 0.8 ounce. The function f of x equals the absolute value of x minus 32 represents the difference between the weight of a box of cereal and the specifications. Graph the functions. What weights do not meet the specifications? So once again, I'm going to take this equation and I'm going to graph it. But now, in addition to each of these being worth 0.1, each of these lines, as you can tell because it goes 32, something, 36, means that each of these lines is actually equal to 2, because this would be 34. Meaning, if I'm going up, I have to go all the way up to here to be my 1, meaning this would end up being our graph. At that point, I would look, and I would see that this says 0.8 ounce is going to be our threshold, so I would draw that. The problem is, especially now, I can't really tell what value that should be. So since I'm not sure, what I would end up doing is the bottom part meets, the top does not, but we're asked what values do not meet. So I would take that 32 ounce and I would add and subtract 0.8 to get my lower and higher limit. The cereal does not meet the specifications below 31.2 ounces or above 32.8 ounces. And that's how we would do this. Thank you very much. If you have any questions, please feel free to email me. Thank you.